Alright, 12.2, surface area of prisms and cylinders. This lesson we're going to do prisms, next lesson we'll do cylinders. So, before we actually get started into this, we need to make sure we understand some terminology about prisms. Okay, first of all, a prism is a polyhedron with two congruent faces called bases. Only two. Okay, good question. Only two. What is a polyhedron? It's made up of polygons. Okay, each side is a polygon. Okay, so I'm going to do my best attempt to draw a rectangular prism. Getting better every day. Okay, so I have my rectangular prism. Now, in this case, this is what we would call a right rectangular prism. Because it goes straight up and down. Okay, it's not tilted off to the side, it's not leaning or anything like that. It's just supposed to be going straight up and down. Okay, so that would be a right rectangular prism. I'm going to name my prism after what shape my base is. Okay, so my base is what shape? It's a rectangle. Now, there are multiple things that you could consider your bases here. Most of us would probably say that's our base, right? Yeah. Because that's what it's sitting on. Okay, but there has to be two of them. Okay, because it's made up of two congruent bases. So your other base would be right there. Okay, so each prism has two bases. One on top, one on bottom. So this would be a base. This would be a base. Okay. The sides going around, which in this case there's how many? There's four, yeah, Royal. Well, they could be. So I'm just saying you guys would probably choose these ones to be because it's already sitting on it. But the right side and then this back side over here, those are both congruent, right? So could they be considered the base? Yeah. The front and the back, those are both congruent, so there's two of them. Could those be the bases?
So the top ones and the bottom ones and the side ones aren't the same?
No. Sometimes they might be, but not in this case. See how skinny this is compared to the side? It's pretty tall. Okay, so if we consider these the bases, and Royal, we'll talk about your question a little bit more here in a little while. I have four sides going around it, correct? In this case, those are called my lateral faces. Because they're definitely faces because they're flat surfaces, which we talked about yesterday. But they're lateral because they're going around the outside. Okay, I don't know the exact definition of what lateral means, but when I think of lateral, I know you got your lat muscles on your side, so I think of side when I think of lateral. I don't know the exact terminology, I guess. Okay, but that means they're on the side and going around. Okay, now these parts where two faces come together, what's that called? That's an edge, right? In this case, it's on the side, so that's going to be a lateral edge. What else would you call that lateral edge? That would also be your height. Good. Okay, your lateral edge is going to create your height for you. Okay, now again, most of this is just terminology, mostly for our upcoming theorem later in the lesson. Okay, so just make sure you understand what we're talking about here. Now, don't get this confused. Okay, this is a right rectangular prism. This next one I'm going to draw, or attempt to draw, struggling. I don't know if you guys can see that is. That's because I got it drawn incorrectly. This should be a solid line. That would be back behind. Okay. So, anyways, what I'm getting at is, think of this like the diagram in your book. It's slanted. Okay? It doesn't go straight up and down, does it? This is not a right prism. Okay, because it does not go straight up and down. I talked with the other class. When we had obtuse triangles, our height could be on the outside, right? We're finding an area of triangles. Our height could be on the outside. Your height is out here on this. Okay, so that's the easiest way to figure out, is it right or is it oblique? This is an oblique triangular prism. Okay, because the height is not actually in the shape or on the shape, it's outside of it. Okay, it's slanted or leaning over. We're not going to work a lot with that today, but understand the differences here. Okay, so the main thing we're getting at today is surface area. So we're going to take a rectangular prism and we are going to find the surface area of that. Okay, so our prism, we're going to make it a little bit different than what we've been doing. Not bad, right? I'm getting better. The measurements don't exactly match or make sense, but that's okay. Use your imagination. Okay, now, if I'm finding the surface area, what does that mean? How much surface there is, right? So that's all of my sides, correct? How many sides do I have in this case? I have 6. So I need to find the area of all 6 sides and do what with them? Add them together. So, what is the area, or first of all, what shape's my base? Are most of you looking at this as the base? Okay, that's the one I would look at too. What's the area of it? 15. How many of those do I have? 2. So for surface area I have 2 times 15, right? What's the front side? 24, because it's 3 wide and 8 tall. How many of those do I have? 2. And then I need my sides, my left and my right, which is 5 by 8, which is, but there's how many of those? 2 of those. Okay, 1 on the right side and then 1 on this back left side. Okay, so 2 times 15 is 30 plus, what's 80 and 30? 158. What would my label be if this is surface area?
Inches squared.
Inches squared, because it is area, correct? Okay. So one method of finding surface area is find the area of each side and add them all together. Okay? And that's not too bad in this case, right? Okay, not too bad. Again, were there multiple options for you to choose as the base here? Yes, but if you have a rectangular prism like that, you just as well go with what's already on the bottom, right? Okay. Now, looking over on the next page, they actually give us a formula as a theorem for surface area of a right prism. Okay. This formula is that surface area equals 2 times capital B plus capital P times H. Again, if you know the stuff, it's probably not too hard of a formula to solve, right? Okay, now, what's S stand for? Surface area. And this next changes a little bit. Capital B is the area of the base. That's why it's capital. Usually when we think of base, it's usually lowercase b. Capital B is the area of the base. P usually stands for what? Perimeter, which it is, but this is the perimeter of the base. A little more specific. And H always stands for height. Okay. So let's go back. We're going to use this exact same rectangular prism that we used in the last problem. And we're going to see if we can come up with the same answer. Because it should be the same, right?
Yep.
Okay. So in my formula, I need 2 times what? The area of the base, which we chose this to be the base, right? So 2 times 15 plus the perimeter of the base. So it's 5 and 5, which is 10, and then 3 and 3 is 6, so I have 16 total, times the what? Height, which is what? 8. Now, before we finish solving this out, let's think about what we just did. I took 2 times the area of the base, which we actually did in the first time we did it, right? Because I have 2 bases. And then I found the perimeter and multiplied it by the height. So, am I still taking 5 times 8 and 5 times 8 for the sides? And I'm still taking 3 times 8 and 3 times 8, right? I just added those all together. Okay, so are you still actually doing the same exact things? Yeah, we just condensed it down a little bit. So this is 30 plus 128, which is 158 inches squared. Did I get the same answer still? Yeah. A little bit quicker. Again, you're condensing things down so you don't have to think about the process as much. And the nice thing about the theorem is you have it on your theorem sheet, so you really don't have to memorize a process. Hey, you can just memorize a formula or be able to find a formula. Okay. Not too bad when they're rectangular prisms, right? What's going to make them a little more challenging? When they're not rectangles. Because rectangles are easy to find the area of. Other shapes not quite as much. Okay, so the next one we're going to do is a triangular prism. Okay. Is this a right or oblique triangular prism?
Right.
It's a right triangular prism. Everything's pretty straight on it. Now, what's the base? What shape is the base?
Rectangle.
Not a rectangle.
Square.
A triangle.
Why is it a triangle and not a rectangle?
Oh, you have to have two to make it a prism.
You have to have two. You have to have two congruent sides. Are there two congruent rectangles?
Yep.
Well, yeah, but there's actually three, right? Okay, so we don't want to use that as the base. We want two. What is there two of? The triangles. So, the hard part about this problem is we have to think about this prism flipped on its side, right? Okay, and I could redraw it flipped on its side, but I'm not going to, so we have to look at it and make it a little bit more challenging. So, in my equation, I need 2 times what? The area of the base. And the base we decided is what shape?
Triangle.
It's a triangle. More specifically, an equilateral triangle. So you got some choices here. You could either use sine, cosine, tangent and find the height. You could use your 30-60 right triangle and find the height. Or you could use what? What's the third one and the fastest? To find the area of an equilateral triangle.
R squared. R squared.
This isn't a circle. Jacob? Nope. That's an S.
Okay.
That's the area of an equilateral triangle. That is on your theorem sheet. Okay, you should be using that. It's going to save you a ton of time. So, in this case, my side is 7. So I have 1/4 of 49 times the square root of 3, right? Okay. Some people in the last couple classes turned that into a decimal. The problem is, with a decimal, you have to round it, right?
Yep.
And we're not done using that number yet. So we're going to try not to round that. What is 1/4 of 49 over 1? It's just 49 over 4. What's 49 over 4 times the square root of 3 over 1? 49 square roots of 3 over 4. And again, some people are trying to type this into their calculator when actually, if you can get this down, it's actually a lot easier just to smash it all together and be done. Okay, you don't have to do any calculations on your calculator at all. So what did I just find here? Or what did we just find here? The area of the triangle, which is our base, right? Okay, so I need to take this number and put it in right here. So I have 2 times 49 square roots of 3 over 4 plus, what comes after the plus sign? The perimeter of what? The base, which is 21. Remember, the base is the triangle. So 7, 7, 7 is 21. Times the height, which is 5. So don't confuse yourself there, because this doesn't look like a height, does it? But it is, because we got to flip this onto its end. So the 5 would actually be going vertical in that case. Okay. So now, how do I multiply these two together? Could I take 49 times 2 and get 98?
Yeah.
Yes. What can I do to make that easier, though? How about I cross-reduce? Can I do that? Since I'm multiplying? So I actually get 49 square roots of 3 over 2 plus 105. Okay. So let's type that into our calculator real quick, see what we get. 49 square roots of 3 divided by 2 plus 105. $147.44 label meters squared. Now, I won't count that answer wrong, but some of you that got 109% on your tests found out that if you leave it in as an exact answer, sometimes that's beneficial to you, right?
That's correct.
Yeah, I gave you bonus for that. So, and the reason I did that is because next year you'll never change anything to a decimal. So you're going to have to start figuring out how to leave things as exact answers. I want to change this a little bit. It's already pretty exact, right?
Yeah.
Okay, I just want to reduce it a little bit and not get a decimal. This is over 2. Can I add it to something that's over 1 right now? No. What do I need to do to be able to add those two fractions together? Yeah, I need to change this common denominator, right? So I'm actually going to have what on top?
210.
So I'm going to have 210 now over 2. So now I can combine them together. Now, are these like terms?
No, but 49.
No, but 49 is connected to the square root of 3. So what we're going to do here, we're going to take the 210. I'm going to put it out in front because it doesn't have radical. Plus 49 square roots of 3 over 2 meters squared. Okay, so either of those answers is acceptable. I like this one because I teach the next class and I know what you're going to have to do with these things. Okay, you're going to have to be able to do this. So we just as well start working on that now. I'm not going to count this wrong, but some of you got bonus on your test because you left answers like this. Or in terms of pi, or there's a few different things that I gave bonus for if you left exact answers. Okay. Biggest thing, make sure you understand what these letters mean in your formula. Okay, and then make sure you understand what is the base. There has to be how many of them for it to be the base? 2. Can you have more than 2? No, you can't have 3. You can't have 1. You can't have 4. It has to be exactly 2 of them to be the base. With the exception of maybe a cube. Okay, a cube's going to have 6 congruent sides, right?
So that's not a prism.
It is. Still a prism. I mean, it's a specific prism. It's a cube. Okay. All right. Flip over. I want to take a look at number 13 real quick. Hey, we'll do that one as a class just so we can make sure we have that understanding down. Give the mathematical name of the solid at the right. What shape is the base? It's a hexagon. Is it a right prism?
Yeah.
So what would I name this? What kind of... A right hexagonal prism. Use the base in the name. Make sure to distinguish whether it is right or oblique. Again, we'll add on to this tomorrow and do cylinders tomorrow.